Our next lecture is Gigabit Ethernet Passive Optical Network Part 1. Now we start with introduction. A new type of optical access network technology is GEPON that relies on point-to-multipoint architecture, and a variety of services are provided over Ethernet by using passive optical fiber transmission. It is also known as EPON. In this, the data is encapsulated with Ethernet and 1 Gbps to 10 Gbps capacity can be offered. The original PON architecture is followed by EPON. There is a connection of DTE to the trunk of the tree, which is called optical line terminal as shown in this figure. Its location is at the service provider and connected to the optical network unit, which is the DTE branches of the tree whose location is in the subscriber premises. In order to achieve the ONU, the passive splitter is used to pass the signals from the OLT and vice versa. Next is Ethernet in the first mile. Ethernet in the first mile, a new study group began the standardization process that was established in November 2000 and is based on IEEE 802.3AH standard. And access to a P2MP topology has been controlled on the basis of multi-point control protocol, which is a function within the MAC control sublayer. The point-to-point emulation sublayer contains the EPON or MPCP protocol. The transmission rate of EPON is symmetric, 1.25 G, distance is 10 km or 20 km, and splitter ratio is greater than 1:32. There are many advantages of EPON that are pointed out by the EFM based on the Ethernet as core technology that includes protocol's maturity, technology simple, extension flexibility, users oriented. The expensive ATM hardware and SONET equipments are chosen by the EPON system so that it becomes compatible to the existing Ethernet network. The system structure can be simplified, cost can be decreased, and upgrade flexibility can be improved. The main focus of equipment vendors is on optimizing the function and practicability. Next is BPON ATM systems. Large IP frames and variable sizes are consisted in the vast majority of traffic across the access network that makes the BPON ATM based systems very inefficient. Therefore, the opportunity has been created to develop pure Ethernet based EPON, quality of service of Gig-E password, and integrating other emerging Ethernet equipment in a cost effective manner. Ethernet has been becoming the ideal transporter for IP traffic over time. After proposing the FSAN members for an ATM or Ethernet PON solution, passive optical network development has begun. The popularity of GBPS in the IEEE 802.3AH working group is low. G.983, the standard of BPON, is used to draw EPON and GPON for the general concepts that work well. The version of enhancements is offered by both of them so that better size IP or Ethernet frames can be accommodated at variable rates Gbps. Next is concept of EPON. The concept of EPON has been introduced by EFM by implementing a point-to-multipoint network topology with passive optical splitters. The highest bandwidth is offered by the Ethernet point-to-point fiber at a reasonable cost. Relatively high bandwidth has been provided by Ethernet point-to-multipoint fiber at a lower cost. The extension of the application of Ethernet was the purpose of the IEEE standard 802.3AH, in which access subscriber networks were included so that a significant increase in performance was provided while minimizing operation and maintenance equipment costs. The range and reach of Ethernet transport has been significantly expanding for the IEEE 802.3AH EFM standard conclusion so that they can be used in the metro networks. A variety of flexible and cost-effective solutions is allowed to service providers by this standard so that broadband Ethernet services are provided in the access and the metro networks. A family of technologies is covered by EFM that has different type of media and signaling speed. Any IEEE 802.3 defined network topology can be used on the subscriber premises, and after that connection is provided to an Ethernet subscriber access network. Maximum flexibility can be achieved by using different types of topologies in the EFM technology. Next is IEEE standard 802.3AH. In IEEE standard 802.3AH, specifications are included for Ethernet access networks of the subscriber and a nominal rate of 1 Gbps that can be expandable to 10 Gbps has been supported by IEEE standard 802.3AH EPON for each channel. The two wavelengths defined these are a downstream wavelength for the shared upstream direction between the user devices. The full duplex links are supported by EFM to define a full duplex simplified media access control. Ethernet architecture divides the physical layer is divided in a physical medium dependent, physical medium attachment and physical coding sublayer by Ethernet architecture. A P2MP network topology can be implemented by EPON with appropriate extensions to the undercoat and reconciliation sublayer MAC control. This topology has been supported by the optical fiber under layers physical medium dependent. Next is physical layer. For P2MP topologies, EFM introduced a family of signaling systems has been introduced by EFM for P2MP topologies for the physical layer that are derived from 1000 base X. The extensions of the RS, PCS and PMA are included with an optional forward error correction capacity. The characteristics of the interface are mapped with the 1000 base X PCS and PMA sublayers. The expected services by the undercoat reconciliation are the PMD sublayer including MDI. There is an extension of 1000 base X so that other full duplex media can be supported. It is required that the consistent environment is there with the PMD level. Medium load interface. The interface between PMD and the physical media, the signals, the physical media and the mechanical and electrical interfaces are defined by MDI. Physical medium dependent. The interface to the transmission medium is provided by the PMD. Depending upon the connected physical medium's nature, the electrical or optical signals are generated by it. PMD is indicated by D and U suffixes at each end of the link in a PON Ethernet, which transmits in these directions and receives in the opposite direction, that is 1000 base PX10D identifies a single downstream PMD and 1000 base PX10U PMD identifies the upstream. There can be a simultaneous use of same fibers in both the directions. There is a connection of 1000 base PXU PMD or 1000 base PXD PMD to the appropriate PMA 1000 base X and MDI can support them. There is a combination of PMD with management features so that the access can be provided via the management interface. Physical medium attachment. The transmission, receipt, clock recovery and align functions are included in PMA. The PMA provides an independent middleway for PCS so that the use of a range of bit-oriented physical media series can be supported. The codification's bit functions are comprised in the PCS sublayer. The gigabit media independent interface is the PCS interface by which a uniform interface to the reconciliation sublayer for all implementations of 1000 Mbps physical is provided. Gigabit media independent interface. The interface between the gigabit MAC layer and the physical layer is referred to the interface GMII. It allows multiple DTE mixed with a variety of implementations from the speed gigabit physical layer. MAC and repeater is included by PCS customers. The GMII precisely defines the PCS interface. The matching of GMII signals is ensured by the reconciliation sublayer that defines the service access control medium. The independent media is provided by GMII and RS to use an access controller identical media with any type of copper and optical PHY. Data link layer. Multi-point MAC control. The standard was supported by the MAC control protocol. There can be implementation and addition of new functions. It is the case of multi-point control protocol. The multi-point control protocol defines one of the functions as the management protocol to P2MP. The devices of the subscriber are accessed by implementing the multi-point MAC control functionality that contains physical layer devices point to multi-point. A point-to-point service is provided by MAC emulation jurisdictions between OLT and the ONU. So this is all in this lecture. Thanks.